After giving conclusion to exception handle, we conclude encapsulation process. We conclude, make it define encapsulation process. Define encapsulation process. Define encapsulation process. English meaning of encapsulate is binding together. English meaning, dictionary meaning is binding together. We call it as encapsulate. That feature available in object-oriented programming. That's a concept. In C language, it is not available because in C language, structure will hold dissimilar data. That's all. It cannot hold other than that variables. It cannot hold. Structure can hold variable. That variables can be similar or dissimilar. There C language ends. From C++ onwards, encapsulate means you can bind variable and function together. That all encapsulate. Encapsulate English meaning is binding together. But when it comes to Java, what happens now? We can bind variable, method, block, constructor, inner class, inner interface, inner abstract class, exception handling components together. So it is the biggest encapsulation process available in Java. So by yesterday, the complete encapsulation process has been ended because I am writing the point today. So the biggest encapsulation process has been ended by yesterday. Suppose if we take inner classes diagram for us, somewhere we had inner classes, we had it. This is, I given this diagram to you already. I posted. But on that day, I not written that statement to you. Today, officially I'm writing. Go with new. I pasted here. Again, this is. But today, why I'm showing this diagram again to you? The reason. On the day, class is holding variable, method, block, constructor. Class will have the features of another class, inner class, inner interface, and so on. Today, the class is holding exception components. The class today updated with exception components. Updated with exception components. Right. So today we are ready with exception components. We are ready. exception components. We are ready with exception components. How many exception components now? Try, catch, finally, the 1 minute, throw and throws. These components we have to know for interview anyway. These components you can write in interfaces, abstract classes. You can write components in other also anyway. This is your complete encapsulation. All of you understood this, right? Complete. This is complete and complete structure of class. Today ended. If anybody asked what you learned from core Java means, to show this diagram. Complete structure of class has been constructed today. Over. Because I am writing encapsulation today. Make it the process of binding all the programming components into a single unit, UNIT, single unit class is known as encapsulation process. The process of binding all the programming components into a single unit class is known as encapsulation process. So why we are highlighting class? Object oriented means class based code only, because class only will have object. Interfaces, abstract classes depend on the classes, you know already. So we highlight the process of binding all the programming components into a single unit class is known as encapsulation process. Today we completed that process. This comparison diagram will be pasted once again, or we are going to send once again. What class can hold? If anybody asked, then you must say, these all things you have to remember it. Class in Java can hold variable, methods, blocks, constructors, features of another class through extends keyword, features of another interface through implements keyword. Class can hold one inner class, class can hold one inner interface, class can hold one inner abstract class. Any disturbances occurred in my class, I can handle by using exception components like try, catch, finally, throw, and throws. Understood this, right? Now, today you take this and show to other technology people, Python people, ask them what their class contains. Go to .NET people, now you compare it, what their class contains. PHP people also has class. .NET people has class. C++ people has class. Your Python people will have class. Wherever the object-oriented, object-based languages available in the market, they'll have a class. You are a Java developer, you can say, if anybody started comparing, don't compare like this. For you, life is there. For me, life not there. Tomorrow, Python will be there. That is not comparison. Subject comparison, what it contains, what your contains. Today you show to them. This is our Java class. So you show your class component to me. Let us compare it. That's a way of comparison. Today the component is ready. On the day one, I written one statement to you. On the day one, I written. So whenever I'm writing a class definition, on the day you are starting, you are entering into this course, right? Define class is on the day power of, I think. So class is a structured layout in Java. I'll write. Yes or no? Na? That repeatedly I'll write one more time somewhere. Whenever the non-primitive data types comes, when the non-primitive data types comes, we highlight that point once again. Object-oriented object. Class is a structured layout and which generate objects. On that day, students should understand, no, I written only variables and methods. But today, complete structure. I asked you to underline on that day. Underline that structured layout. Today, I completed my structured layout. Complete class construction has been done by me as a trainer in your live class. Understood the statement now? It is a structured layout. Means what? Complete class structure has been constructed. Part of object-oriented programming, part of your features, object-oriented features. Today, complete structure has been constructed. Complete class structure constructed here. Complete class structure constructed here. Understood this now? Now the class is giving one object. Now object class will hold some members already, static members, and non-static members it has to give to the object. So we say object is a storage to a object is a storage related to class. We say related to class holding non-statica, statica, non-static, simply you can say instance, non-static members of class. So members of class. Sir, at last today I know complete structure of class. I know, sir. The class is giving one object to me. Interface is not giving object to me. Abstract class is not giving object to me. Who is giving object now? Class is giving object. What is that object? One storage. The storage belongs to whom now? One class. What the storage holds? The storage holds the non-static members of class. Clear everyone? Right. Then what is this abstraction, sir? Sir, what is this abstraction? Abstract English meaning is nothing but physical existence not available. Abstract component means physical existence not available. Abstraction means hiding. Abstraction means what now? Hiding the process indirectly. Now make it define abstraction. Continuation. Here continuation. Define abstraction process. Hope I written. I think I cannot write. I cannot remember. Define abstraction process. Define abstraction process. The process of hiding, the process of hiding non-essential things from the user and showing only essential things. The process of hiding non-essential things from the user and showing only essential things is known as abstraction process. The process of hiding non-essential things from the user and showing only essential things is known as this is general meaning of abstraction. The best example for abstraction is generally in the market. Go to ATM center and withdraw the amount. That's called abstraction. Take one ATM card belongs to SBI. Go to HDFC Bank and withdraw the amount. Amount will come. But what happened in the background? Not needed to the user. You came to ATM center to get the amount. Get the amount and go. That is called your essential thing. How it integrated, who integrated, what it integrated, we hide from you. That is known as abstract. Of course, developer only write that code. That's called abstract. Something is not needed to the user. Don't show it. Something is not needed. Daily you will make a chatting. No. Hi means your friend will say hi. Your friend is in US, you are in India. Sir, how it hi traveled, sir? I cannot walk in Amirpet correctly in the rush hour, sir. Yes, sir, no, na. In the rush hour, I cannot walk from this building to Satyam Theatre. It is taking 10 minutes time to walk it as human being, personal intelligence. But high message will come within fraction of seconds. Who is in the US? What happens, sir? I mean, abstraction not needed no for you. You are expecting one message reply from your friend only, no? So hiding the non-essential and showing the essential. That concept name we call it as abstraction. Sir, can we do this? Yes. In Java, we use interfaces. We use interfaces and abstract classes to perform abstraction process. In Java, we use interfaces and abstract classes to perform abstraction process. Underline interfaces, underline abstract classes. So wherever the interface program is there, wherever the abstract class program is there, that comes under abstraction. The best example of abstraction for you, multi-threading chapter is an abstraction. Servlet programming is an abstraction. Servlet program will speak to HTTP protocol, actually, server program. It is never revealed to a user. It gives an answer to you directly. What happened in the background, it will not show. That is called abstraction. So abstraction can be performed by using interfaces and abstract classes. So simply in the front end document here, sir, abstraction means hiding non-essential things and showing only essential things is known as abstraction process. So example for it we show is as interfaces. If you know abstract classes, if you know, automatically abstraction process is available in your program. Encapsulation today ended. The process of binding all the programming components into a single unit class is known as abstraction. Ended. Now what is pending there now? Polymorphism is pending or not now, right? So inheritance. Anyway, how many ways are there in types of inheritances? For interview, say 5. For interview, may say how many now? 5. What are they? Single, multiple, multi-level, hierarchical, and hybrid. Based on real-time market or applicative area, how many ways are there now? 2 ways. This is for applicative, right? Okay. So interfaces, abstract classes comes under abstraction. The class construction comes under encapsulation. Separate training available on inheritance for you. We done already in many levels. So now the concept is what now? Polymorphism in Java. Small discussion we are going to do. Make it. Star mark IMP. Polymorphism. Polymorphism in Java. The process in which the process in which the programming components having more than one form, the process in which the programming components having more than one form is known as polymorphism. Poly means many. Morphism means forms. The process in which the programming components having more than one form is known as polymorphism. It's a small concept actually. These many forms are categorized into two types. Polymorphism. Now, polymorphism is categorized into two types. Many forms categorized into two types. So meaning, one is dynamic polymorphism and static polymorphism. So 9am batch confirmed. That is not advanced Java. Right? Yesterday they confirmed. Right? So dynamic polymorphism and static polymorphism. Dynamic means runtime or execution time. Polymorphism means many forms. Many forms at execution stage is known as dynamic polymorphism. So simply the polymorphism at execution stage, the polymorphism at execution stage is known as dynamic polymorphism. Dynamic polymorphism. Or you can say runtime polymorphism. The polymorphism at execution stage is known as dynamic polymorphism or runtime polymorphism. Example for dynamic polymorphism is method overriding process. Method overriding process. Method overriding process comes under dynamic polymorphism. Already we done the method of overriding, no, right? How overriding comes under dynamic means see there. General analysis. Right. So repeatedly I written one program repeatedly to you. The program is bank transaction. Always I written. I'll take like this. Transaction. I will take it. Here I took the method no always. One minute. Transaction. One interface. Always. We had a method here. Void process of into some amount always. We took one abstract here. Now always we write two implementations available. Withdraw and deposit. Deposit. We done this 3-4 times already. What is the rule of implementation? Means, sir, taking that process method and constructing the body. Logic. Withdraw logic. Void process into amount. Deposit logic. Now, always I kept this kind of diagram. Now, process has two forms. Same method only. Process, one method. Having two forms. One is withdraw form and one is deposit form. So one is withdraw logic and one is deposit logic we had. So always we give a choice to the user. You want to withdraw, you want to deposit. Generally means what? When the execution started, process is having two forms. One is withdraw form, one is deposit form. That only we say. Through overriding process, we can provide more than one form to a method. while execution process. Because of this reason, overriding comes under dynamic many forms. Dynamic means runtime. When execution started, the user will have a choice, two choices. One same method only process, but one is withdraw logic, one is deposit logic. Make a statement. Through method overriding process, through method overriding process, we can have more than one form, at execution time. Through method overriding process, we can have more than one form at execution time. Execution time. Because of this reason, method overriding comes under dynamic polymorphism. Comes under dynamic polymorphism. Through method overriding process, we can have more than one form at execution time. Because of this reason, method overriding comes under dynamic polymorphism. Static polymorphism, if we take it, the polymorphism at execution stage, not execution, the polymorphism at compilation stage is known as static polymorphism, or you can say compile time polymorphism. You can say the polymorphism at compilation stage is known as static polymorphism or compile time polymorphism, you can say. So example for static polymorphism, we show method overloading process. Both discussions already completed. Overriding, overloading. Method overloading process. Sir, how this method overloading comes under static? That will come. What is the definition of method overload? More than one method with the same method name differentiated by their parameter list or parameter type is known as method overloading process. More than one method with the same method name but differentiated by their parameter list or parameter type is known as method overloading process. Suppose if I take one method like this, I'll take one project as polymorphism. I'll take it. Polymorphism applications. Like this. Always I'll take one package, test. Under test, I am taking one class. I'll take a class as a display. I will take it. Now this display method, I want to take overloaded methods. I want to take it. So public void DAS. Suppose int a comma int b, I'll write it. This is one method. Same method I will write it. If I take same method, error will come. Why? Means compiler is giving error. Means compiler is checking the form. Yes or no? It is giving that duplicate method DAS int comma int. So duplicate method, one message raised by your compiler, means cross checking the method. Cross checking the method. So these two forms are checked by the compiler and saying that it is duplicate. Then I must change it. One I will take it as a float. One I will. So it says okay, they are different. Again I'll take one more. It says error because same duplicate method. Means what? Compiler is identifying the forms. So what I'll say, I'll add one more as int c. Now there are three forms available to you. One form having two int parameter, one form having two parameters, one int and one float. One form is having three int parameters. So display method is having three forms. At the compilation stage, make a statement. Note. Through method overloading process, through method overloading process, through method overloading process, we can have more than one form, to a method by differentiating parameter list or parameter type. Through method overloading process, we can have more than one form to a method by differentiating parameter list or parameter type at compilation stage, because that is checked by the compilation stage. At compilation stage, through method overloading process, we can have more than one form to a method by differentiating parameter list or parameter type at compilation stage, because of this reason. Method overloading process comes under static polymorphism. Static polymorphism. Through method overloading process, we can have more than one form to a method by differentiating parameter list or parameter type at compilation stage. Because of this reason, method overloading process comes under static polymorphism. So example, I took display of int comma int, display of int comma float, display of int comma int comma int. So three methods by differentiated by their parameter list and type. No need to copy that class, not needed. Overloading you know already. Right. This is the fundamental to be said by you when the interview is there. Polymorphism. Poly means many, morphism means forms. Whether your language supports polymorphism or not. You can say, yes, my language supports. One is with method overriding, one is with method overloading. So through method overriding, same method can have more than one form at runtime. So it comes under dynamic many forms. Through method overloading, I can have more than one form at compilation stage by changing parameter list or type. So overloading comes under static many forms. The theory. Now every program what we write, they have to go for compilation stage and they have to come out of the compilation stage for execution. In the compilation process, compiler will check three components: static components, private components, final components. The statement star mark IMP. The compiler at compilation, the compiler at compilation stage will control the following keywords. The following keywords. One is static. Compiler will understand static. Compiler will understand private. Compiler will understand protected. Sorry. Will understand final. Static, private, and final. These three keywords and these three keyword related components are under the control of compiler. Control meaning is compiler will understand their syntaxes. Compiler will understand their declaration rules. Compiler will understand their behaviors also. The compiler will understand. Because of this reason, we say these three keywords are under the control of compiler. So if we take static, make us adding static. The following are the static programming components. The following are the static programming components. Static variables, static methods, static blocks, static classes, static interfaces, static abstract classes. Static variables are available, static methods are available, static blocks are available, static constructors not available. Anyway, static classes available, static interfaces available, static abstract class also available. So what is missing here means static constructors. There is no concept of static constructors. Static constructors in Java. There is no concept of static constructors in Java. There is no concept of static constructors in Java. We don't have. So how many components available in the static now? 6 components. Variables, you know static variable already. Yes or no? Static variable, static methods, static blocks, you know. Static classes, static interfaces, static abstract classes, they are inner components. So you can have inner class as a static, you can have inner interface as static, you can have inner abstract class as a static. So static constructors not available. All these components has been covered to you. We are underlining. So no need to write the programs. Up to now, I not written any program. Absolutely. So they are all completed part because conclusion part it will be like this one. Overriding you done inheritance chapter. Overloading you done inheritance chapter. Okay, right. Static from day one onwards, part by part, part by part, part by part. We covered everything and came already. So now make a siding private not covered. Star mark IMP private. The following are the private programming components. The following are the private programming components. The following are the private programming components. A. Private variables. Private methods. Private constructors. Private classes. Private variables, private methods, private constructors, private classes. Total 4 components available in private. Your language supports private variable. Your language support private methods. Your language support private constructors. Your language will support the private abstract classes will be supported. Clear everyone? Right. Okay. Now what is missing here means private blocks not there. Private constructors, private interfaces not there. Private abstract classes not there. Make it. There is no concept of private blocks, private interfaces, and private abstract classes. These concepts are not available in your language. If you write them, error will come. They'll ask a private interface or private block, they'll ask. So define private block, or can we have a private keyword for the block? That they will not ask it. They'll ask interface. We are declaring public interface now. Can I write private interface? They'll ask. Immediately student will say anyone answer. If he says correct, he'll ask one more question. Why he'll ask one more question means he kept it trila, he knows. When you say the correct answer, he'll ask one more question. Observed in an interview. If you say the second one, he'll ask third one on it. If you say third one, he'll ask fourth one. Why means whether you are giving trila, you know na. Because student will say one rough answer. Because he want to know, he want to judge it. He knows the concept. First only you say wrongly these components. Within 2-3 questions, he'll finish off and he'll send it away. It is you don't know the components from first. Language. Language means components first. Java language means components first. The many people will don't know static constructor not available. They are all called components. If you don't speak components for 2-3 times in the interview, they'll write a negative one. Negative, they'll write negative. Negative means you don't have a concept. He trial and came. So remove him. That's the concept. Language, that only. Language means you must know everything. No choice. Choice not there. All components should be known. Whenever the private comes, only 4 are there. Remaining 3 are not available. So point. Now you take one by one. Private variable, private method, private constructor, and so on. Make it. The variables which are declared with private keyword are known as private variables. The variables which are declared with the private keyword are known as private variables. Right. The variables which are declared with the private keyword are known as private variables. Look here. I'm taking one program. The program what I'm taking is sir, I'm taking 2 packages always. Always I'll take test 1 package. M-access 1 package. So inside this test, I'll go with P display. I'll go roughly 1 class. I will take it. Now inside this, I'll take a method. Sorry, variable. I'll take it. Private int k is equal to 100. Already you know the access modifier. What is access modifier? Private. Private is accessed inside the class. It will not come out of the class. So private will not come out of the class. If we try to access here, if you try to access into another class, you cannot access. If I have one class here, demo poly 1, I'm taking one program, polymorphism, main class. If I try to access from here, error will come. I'm taking P display, I'm taking. While I'm typing, will observe it, all private components. Inside the package test, we had a class. Inside this class, I'm taking one private int k is equal to 100. I'm taking. I'll go for main class. Demo poly 1. Demo poly 1. I'm taking. I can import the class. Import test dot p display. Importing means available. Making class available. Making class available. That is called import, not loading. Making that class available means you can access. Now I am accessing the variable A. I am accessing. The variable A is a non-static, no? Non-static means I must create object or not now, right? You can create object. P display some OB is equal to new P display. Now this is one constructor call, yes or no? What kind of constructor call now? Zero parameter constructor call. Zero parameter constructor available or not available? Zero parameter here not available or not available? Not available. But what constructor is added now? Default constructor is added. Default constructor automatically added. Using this OB, I am displaying the variable. System.out.println. I am trying to display the k variable. So the value k. The value k. OB dot k. It will not come. Why it will not come means visibility not there. The field p dot display dot k is not visible because of its private access modifier not accessed outside the class. You know this concept, right? Okay. You cannot access. So this is error. For you, access not there. So what is the coding rule now here? Coding rule. Private variables are accessed only inside the class. Private variables are accessed only inside the class. Only inside the class. Now look here. Suppose inside that class, I am taking one method here. Void some access. I am taking one method. This method is non-private, means public method. I'll use this method as what method now? Public method, non-private method, public method. I'll take it. Public method will come out now. So public method can come out. So here I am taking public void access. I am taking this void access displaying the variable. This void access displaying the variable. I am accessing the private variable. Now system.out.println, the value k I am printing. the value k I am printing. Whenever I print value k, error will not come. Why means this method, this variable belongs to same class now, right? I can call this access method outside. I can call it. So ob dot access. So that k variable will come out. K variable coming out not. So what is the other way now? Sir, we can access private variables using non-private methods of same class. Only coding rule. Now private variables are accessed only inside the class, which means accessed by the non-private methods of same class. Non-private methods of same class. Non-private methods of same class. All of understood this statement, right? Sir, where we can see private variables? Note. In real time, private variables are used in real time. Private variables are used in bean classes and Pojo classes. Pojo means plain old Java object, you can say. In real time, private variables are used in bean classes and Pojo classes. Pojo means plain old Java object. Bean classes is a term available in servlet programming, and Pojo class term is available in ORM tools. Any tools available, object relation mapping tools are available. You can use the word known as Pojo. There the rules of your variables is must be private. It's a concept. Now make private methods. The methods which are declared with private keyword are known as private variables. Private methods. The methods which are declared with the private keyword are known as private methods. Same coding rule. Private methods are accessed only inside the class. Private methods are accessed only inside the class, which means accessed by the non-private methods of same class. Non-private methods of same class. Private methods are accessed only inside the class, which means accessed by the non-private methods of same class. Suppose if I take one private method here, if I take one private method here, private void DAS, if I take one private method here, roughly, this private method cannot be accessed here directly. I'll take one private method here. Private void DAS, some int p with the parameter I'm taking. So we are trying to display this method with one some message. Private DAS of p. Now system dot out dot print ln the value p is equal to plus. I'm trying to access from here. Error will come. Ob dot DAS of 1 1. So not visible. The method DAS from the type P display not visible. So this is error. You cannot access variable, you cannot access method. But you can call by using this access method. This dot display of some P. You can take this P and give a parameter. This access method can take the value from here and give it. Run it. Ob dot access. Run it. You get answer. So what is the rule here now? Private variables are accessed by the non-private method of same class. Private methods are accessed by the non-private methods of same class. Clear about this statement? Right. Okay. Now see there. Now comes your private constructor. Third one is what now? Private constructor. Make it. Private methods we never use in the market. Very less. Private constructors. The constructors which are declared with private keyword are known as private constructors. The constructors which are declared with private keyword are known as private constructors. So I am declaring one constructor private. Right. See there. I am writing one private constructor. Private. private, P display. Now this is one construct. Now, private variable accessed inside the class. Private method accessed inside the class. Private constructor also inside the class only. Yes or no? Right. See there. If I write private here, one constructor with private P display, I return private constructor. Whenever I return private constructor, you cannot create object. Error is coming or not now? Understood this? You cannot create object here. Why, sir? This is constructor call now. Now constructor is private constructor, public constructor, private. Private constructor will not come. When you cannot create object, how you will access this method? So, coding rule. Private constructor is executed when object is created within the same class. Wherever the class is there, inside that same class, you have to create object. So, object is available in the same class only here. P display some OP is equal to new P display. All of you understood this? Now object is available here only. Right. You cannot create object here. But whenever you want to access this reference, where is this? So declare has public. Suppose declare that object reference as what now? Public. Declare as what now? Static. Static you can access with the class name or not now? Yes or no? Right. So bring that over here. So P display. So P display dot OB. We're accessing one variable or not now here? You brought the address no? Yes or no? So OB you are bringing from where now? Class. How you are bringing now? Using P display dot OB loaded here. So the answer will come. So what you observe here now? When the private constructor is there, the object is created inside the same class. Make a statement. Coding rule. Coding rule. Private constructor is executed. Private constructor is executed when the object is created inside the same class. Private constructor is executed when the object is created inside the same class. So privates will not come out of your class, no? Inside the same. That's the meaning. Of course, we declare that object reference as a static public and we're accessing outside temporarily. But actual rule is private constructor is there means object is created inside the same class. All of you clear the rule? Right. Okay. Now comes here. Private classes. Private classes. The classes which are declared with private keyword. The classes which are declared with private keyword. The classes which are declared with private keyword are known as private classes. Private classes. See there. I am declaring one private class. Private class is only inner class. You cannot declare outer class as private. Private outer class not there. Only inner class. So now I am taking one inner class. Inside this, I am taking one class. Private no. Private class. Subclass 2, I will take it. This is private inner class. One method I will take it. Public void sum M2, I'll take it. Like this. Now system dot out dot println. Inner class M2. I'll take some Z, I will take it. Now system dot out dot println. The value Z is equal to plus Z. Private classes will not come out to create objects. So this private inner class object is created inside this. There is there no subclass 2 OB2 is equal to new subclass 2 OB2 dot M2. This is Z. It is taking Z here. Into Z. So what you observed here now, sir? This non-private method only accessing everything, you know. Non-private method accessing variable, non-private method accessing method, non-private method accessing class. So all non-private methods we are executing with the, all private components we are executing with the non-private component. So here I'll pass some 2 to 2. Answer is coming or not now? What is the coding rule now? Make it coding rule. Private classes can be declared as only inner classes. Private classes can be declared as only inner classes, and private inner class object is created inside the non-static, inside the non-private method of same class. Is the rule. Private classes can be declared only as inner classes. And private inner class object is created inside the non-private method of same class. the rules. Example, I took pdisplay dot Java. I took demo poly1 dot Java. This is one main class and the output. So all these are private components. So private components, they never come out of your class directly. You have to take the support of non-private method of same class. That's the concept. All of you understood the theoretical of this four? Yes or no? Right. So after that final tomorrow, half an hour final, then polymorphism will be ended. Right. Take a break. I'll upload the notes. Yesterday's notes, today's notes, two notes. 28, 27, 28. Thank you very much for today. Take care.